Hey everybody, welcome to Math with Ace. Ace here working on statistics today. We are calculating a confidence interval for two means, which is a t-interval. And we're going to be working through the four-step process where we make our statement, we check our conditions to make sure it's valid for us to perform these calculations. We run the numbers using technology, and then we draw our conclusion. So let's get into the important components that have been given to us for this problem. A manufacturer is comparing two types of batteries to determine whether there is a difference in their average lifespans. In a random sample of 40 battery A units, the mean lifespan was 520 hours, with a standard deviation of 60 hours. A random sample of 35 battery B units, mean lifespan was 485 hours, standard deviation of 55 hours. Perform the four-step process to estimate the difference in the true population mean lifespans of the two battery types at 96% confidence. So what are we doing? We are creating a confidence interval. And at what level? 96%. And what is it that we're talking about? What is this problem about? Well, we're given mean and standard deviations. This problem is about means. So it is the mean difference. And remember, the parameter symbol for means is mu. So we're talking about mu A minus mu B, where we need to define what A and B is. And that is the true population mean difference in battery lifespan for battery A and battery B. We have defined the confidence level. We have defined our parameter symbols. We've defined the parameter, and we have given the context of the batteries. That's what we need in this component. So now, after we've done our state, we want to plan by checking our conditions. The first thing that we need to look at is, was it random? Well, we said random sample battery A, random sample battery B. So for random, both battery A and B were randomly sampled. And then we also need to verify independence. And for independence, the sample size needs to be less than 10% of the overall population, or we run into issues with sampling with or without replacement. So sample A was 40. 40 times 10 is 400. Sample B was 35 times 10 is 350. This is a battery manufacturing plant. We've got to assume that there's at least 400 batteries of type A and 350 batteries of type B. Now to check the large counts / normal condition. For means, you have three things that could be true. The population could be normal for both of these given, or the sample sizes could be at least 30, so we could use the central limit theorem to say, yes, it's going to follow a normal distribution. Or if neither of those are true, then we would need to graph these and see whether the graphs didn't have outliers or skewness. Luckily, even though it doesn't say that the populations are given to be normal, we do know that the sample sizes are at least 30. So NA of 40 is at least 30, and NB of 35 is at least 30. So by the central limit theorem, we are able to perform normal calculations. So conditions are met and we can proceed. You can calculate this confidence interval by hand. We're going to go ahead and use technology. But what we're looking for is our sample sizes, what the mean was, and the standard deviation for the samples. The mean of the first one was 520, and the second one was 485. Standard deviation of the first one was 35. Nope, it was 60, and the second one was 55. So now we're going to pop over to Stapplet. And these are numerical data, so this is quantitative, but I'm talking about one variable of lifespan. I happen to have two groups. So this is one quantitative variable, multiple groups. So now what we're going to do is we're going to say that we're talking about battery lifespan. And we don't have raw data. I don't have a bunch of values for a specific battery A and battery B, but we do have mean and standard deviation. So for battery A, the mean was 520 with a standard deviation of 60 and a sample size of 40. Battery B was 485, 55 standard deviation and 35 sample size. And from there, what I can do is begin analysis. And this is where I calculate my interval. It's a T interval. I'm not using conservative degrees of freedom, but I did want a 96% confidence interval. Conservative degrees of freedom, if you've read the book, was about whether or not you're using the smaller of the sample size minus 1. We're going to go ahead and let the computer calculate the degrees of freedom using the formula for two variables. So when I perform inference, I get a lower bound of 7.224 and an upper bound of 62.776 with the degrees of freedom 72.83. And so it's okay that the degrees of freedom are not a whole number because of the formula that was used. So now in our conclusion, we draw a conclusion based on what we found. So we are 96% confident that the interval (7.224 to 62.776) captures, and this is about what we're talking about, mu A minus mu B, the true population mean difference in battery lifespan for batteries A and B. And from there, what we can see is that this is battery A minus battery B, which means battery A actually lasts longer than battery B because the interval is positive, and there is a difference. 0 is not in the interval. So hopefully this was helpful. Thanks for watching.